All right, good morning, Trinity Classical Academy. Once again, it is I, Mr. Bourgeois, here to greet you and wish you many good tidings during this period of quarantine, a very historic period of time that we live in right now. I'm super excited about it. During this historic period of time, I know many of you are looking for ways to support local businesses that might be suffering and hurting in the midst of quarantine, and hopefully before Nebraska shuts down even as badly as some of the other states. I want to call out one business real briefly. I know this is like a commercial, but I don't personally know these people very well, but there's a husband and wife that run candy wrappers. They're a very nearby in the neighborhood, I would say, of Trinity Classical Academy, St. Paul's Lutheran Church, and they are a husband and wife candy shop. They're in that little mall area nearby where Half Price Books is. And so they hand make their own chocolate truffles, which are sublime, and gourmet popcorn. They're hurting right now because of the quarantine, obviously, but also one of their largest customers, I think their number one largest customer she mentioned was the Children's Hospital that would order a bunch of popcorn each week, just kind of for their staff, and like here, have a little bag of the really amazing gourmet drizzled popcorn. And because they're doing a lot of prep work and stuff for anticipating a large boost in patients, they are not receiving those orders anymore. And so that customer, losing that customer, is jeopardizing their ability to pay rent and stuff like that. And I would really hate to see this business go under. I was there the other day because I ate all of the licorice that I received during Teacher Appreciation Week, which I appreciate very much. It was yummy. And I went over, I was in the area and I popped in to pick up licorice and struck up a conversation with the proprietor. And I asked, hey, how's it going? And she's like, this is terrible because it's Easter. I should be busy and I'm not. And so they have an online ordering portal. You can, if you're concerned about going in, I'm not sure. I haven't completely checked out their website, but it looks like you can order online and probably just go and pick it up. And so you don't have to go in and risk, exposure and things like that. So, so do check them out if you get a chance. They old-fashioned candy store, like from the 1920s. It's something amazing. All right, enough of that. Now, looking at page, let me zoom it back out. So looking at page 140, there is a hands-on activity, which I know I've been kind of poo-pooing the hands-on activities a little bit and saying, whatever. This one I think is actually pretty doggone cool. You don't have to do it, but I want you to just kind of look at it with me while I talk about it. It's a proof for the volume of a pyramid and the volume of pyramids, prisms, cones, and cylinders. You make it out of paper and then you fill it with rice, and then you see how much rice fits in a similar thing. So what I mean by that is, and I think I drew the wrong one. What we actually want here is a triangular prism, not a rectangular prism. So something like this. So all things equal, imagine that these bases are equal. The same base, the same height. The pyramid would be 1/3 the volume of its prism counterpart. Similarly, the cone would be 1/3 of the volume of its cylindrical counterpart if they have the same base and the same height. So the hands-on activity that starts on page 140 and goes through page 141, it's a proof of the formula. So we know that any kind of a cylinder or a prism, you've got the volume. So a cylinder or prism, the volume equals the area of the base times the height. So for a triangular prism, the area of the base would be 1/2 BH is the area of a triangle, so that's the surface area of the triangle. You multiply that by the height of the whole prism, maybe I'll call that a capital H for height of the whole prism, and you get the area of this jobby up here. For a cylinder, it's the area of a circle times its height to get the volume. And again, volume would be how much space it takes up, or phrased differently, the volume of the interior would be how much stuff it can hold, the space of the stuff that it holds on the inside. So like water or whatever. And if you do this hands-on activity, you construct a cone and a cylinder, you fill it up with rice, you pour the rice from the cone into the cylinder, and you go, oh, look, it's not quite full. You fill up the cone again with rice or sand or whatever, you pour it into the cylinder, oh, look, it's still not full. You do it again, and you're like, oh, after 3, it's full. That means, haha, it's proven. A cone is a third as big as has a third of the volume as a cylinder of the same height and width. I think that's really cool. I love doing stuff like that, little proofs. So yeah, cone, pyramid, we're doing those today. Cones and pyramids are 1/3 as big, and I think if you do this hands-on activity, and you're kind of a kinesthetic learner where doing something makes you really remember it, makes it stick, you'll see, and it might be easier to remember that you're looking at a 1/3 right there when you're dealing with a cone or a pyramid compared to its more filled-in counterpart. Fun times? Erasifying. Annihilationizing. Okay, we're going to turn the page over to be on the page 142. All right, find the volume of a pyramid and a cone. Once again, I know I mentioned this in the first video in this chapter, that when we're dealing with a pyramid or a cone, I'll draw a cone because why not? The height is always has to be straight up and down, which of course I didn't draw. The height always has to be the straight up and down number. So this is the height, not this, not that, but this. This is the height of the pyramid or the cone. It's from the very center. If you were standing on the inside looking straight up at the apex, you'd be looking up the length of the height. Once again, if Superman flew and decided to stand on top of your pyramid with his flowing red cape, you would ask, how high is Superman? That's the height of the pyramid that you're talking about. Not Spider-Man tries to get up there, and so he climbs up the side. No. Not how long did not how far did Spider-Man climb up the side, but how high is Superman after he landed there. Capiche? That's the height. Ignore Spider-Man. Look at Superman. So we have to find the area of the base. Remember, area is in 2 dimensions, so we're going to have inches squared or square centimeters, something like that. So before you find the volume of the pyramid, you have to find the area of the base. Then you use the formula below. In the formula, B is the area of the base, and H is the height. I kind of like the way that they do this. This is not the way I learned in school. We learned it with this expanded out. So instead of just, hey, base, they were like, hey, it's, 2 pi r squared times height. Or for a pyramid, it was, length times width times height, times height. Or for a triangular pyramid with a triangular base, it was 1/2 base times height times height. So here they give you the generic formula, the area of the base times the height. This applies to any of them. It's wonderful. I really, really, really like it because that's less you have to memorize. You should already know. So this B might be the area of a circle. It might be the area of a square or a rectangle. I guess a rectangle. We'll say rectangle. Rectangular prism, pyramid, rectangular pyramid, or it might be a triangle. So base could either be, nope, wrong one. Could either be pi r squared, or it could be length times width, or it could be 1/2 of length times width for a triangle, right? Like half of a square. So whatever the bottom of your pointy coney thing, can we think of a generic word that encompasses pyramids and cones? Things you definitely don't want to step on if they're on the ground. So your foot stabber thing that you don't want to step on, how much of your flesh does it displace when it punctures you? That's the volume. So let's look at example 6. Put some meat on this plate here. See you later, Superman. All right, find the volume of the pyramid. What is the volume of the rectangular pyramid? They show you one. It says it's 8 centimeters high. Let me continue to murder shapes over here. It's 8 centimeters high. It's 6 centimeters this way, 4.5 centimeters that way. And it's square on the bottom. That was a terrible square. It's okay. I'm sure you'll forgive me. Oh, and that should be dotted because we can't see it. It's behind us. So height is h. 8 is h. 6 is this one. 4.5 centimeters is that one. Let's chug it into this formula. So remember, because it's not a prism, it's a pyramid, we're going to take the volume of the prism and we're going to take a third of it. A third times the base times the height. The height is 8. I'm going to go ahead and sub that in right now. The base is going to be this formula over here. Did you see me circle that? Watch again closely. 1/2 times the length times the height. So 1/2 times 6 times 4.5. So the base, I'm just going to expand it over this way. We'll use blue. So 1/2 of 6 times 4.5. That's going to be 3 times 4.5, which is going to be 12, 13.5. We can use calculators. I'm going to use calculators. 13.5. I was right. Okay. I need to have more confidence in my mathematical skills. So we have 13.5 times a third times 13.5 times 8. I'm just going to plug it in. Times 8 equals that, divided by 3 equals that. You get 12. Haha. Hang on a sec. What did I do wrong? Oh, times the height. I forgot to multiply the height in there. Wait, did I? What is going on? Ow! You guys, here's the mistake I made. All right, pause the video and see if you can find the mistake I made, and then I'll tell you. All right, the mistake I made. I found the area of a triangle. It's not 1/2. This is a square bottom. Ugh, look at that. So this is a square bottom, you guys. I didn't have to half it. Square. So never mind about this. It's not 13.5. It's 6 times 4.5. That should be 27. So yeah. So 27 times 8 divided by 3 is 72. It's right there in the book. I could have just read the book, but I didn't want to. I wanted to solve it live. I want to do the math, not look at the math. Right? Am I right? That's right. Sadie knows I'm right. Saderator. So, folks, do guided practice. We're on page 143. Solve it. Do it. Do it now. 143. Guided practice. Pause and stuff. Okay, unpause and stuff. You did guided practice number 1 and 2. Did I say 1 and 3? Do guided practice number 1 and 2, and then unpause. Look at all this math. Let's clean this mess up. Yes, I'm always this weird. Base of so okay, so here are the answers. Again, there's all those blanks. If you just came up with 15 cubic centimeters, you'd be correct for number 1. For number 2, if you came up with 121 meters cubed, you can skip ahead a couple of minutes until we start on example 7. All right. If you want to see it worked out, here it is. The base of a pyramid is a right triangle. Now, Mr. Bourgeois knows what he's talking about because it's a right triangle. Yep. I should really get like a theme song, like a radio show where they start playing interlude music. Strike up the music, the band is all here. The Pennsylvania polka. Okay, so it's 6 centimeters high. I'm just going to take their word for it. 5 centimeters that way, and 3 centimeters this way. So we're going to use 3 as the height, not like it matters. Because it wouldn't matter, because if we expand this out, if we were to make this a cube, a rectangle or whatever, it would be a rectangle cut in half. So we're fine. What's the volume of the pyramid? There we go. Just like I solved it last time. So it's going to be 1/3 times 1/2 of, so this is the base. Remember, let me plug it back in here. So 1/3 of the base and the height. So the base is going to be 1/2 times 3 times 5, and the height is 6. So 1/2 times 3 times 5 would be half of 15, would be, this should be easier, 7.5 times 6. I can easily multiply 1/3 by this 6 and I get 2. And so 2 times 7.5, which should be easy because I just did it in reverse up here. It'll be 15, and my units are cubic centimeters. Let me try that again. My units are 15 centimeters cubed. And a well-dressed one with hat and shoes. Sweetness. All right. 15. A square pyramid now. So this is number 2. The square pyramid. The height is 12. I'm just going to write these down. If you want to draw it, you sure can. Height is 12. If the side of the base measures 5.5 meters. So the bottom of this pyramid is a square, which means it's 5.5 times 5.5. What is the volume of the pyramid? Sweet. So 5.5 squared. That's why they call it squared. Did you ever wonder why they call it squared? Because a square has it multiplied by itself. One side multiplied by itself. 5.5 squared. I'm going to calculator that. 30.25. That's my base. The area of the base. The bottom of the pyramid, right? It's also 12 meters high. I'm going to take 1/3 times the base times the height, which is 12. I'm going to plugify that into my calculator. Divide that by 3. I get 121. And then I have to look at the problem again to check my meters, check my units. It'd be cubic meters because we're doing volume. It's in 3 dimensions, a 3-dimensional shape that we just calculated. Super cool, you guys. I'm having a lot of fun. I hope you are too. Example 7, here it is. If you skipped ahead, this is where you should rejoin us. That's the rejoin the lesson. If you're like, I don't need to see him solve the guided practice, I got it. Now you can jump back in. We're doing example 7. No, stop it. I want to do this. Click, click, click. All right, now you can rejoin us. Example 7, there. Find the height of a pyramid given its volume and its base. That is just like what we did in the last lesson where we had everything else, but we're missing one of the variables. So it says if there's a pyramid below that has a volume of 260. So here we have our thing, V equals 1/3 BH. This time they're giving us that the V equals 260, and they're giving us that it's 15, the base is 15 times 8. Why do they keep making me draw 5s, those guys? 5s are like the hardest thing to draw on a touch screen, and they keep making me draw 5s. 15 times 8. See, why can't it be more 8s? Or 3s, or I don't know, 6s. So they give that to us. So here we go. So 260 is going to equal 1/3 times 15 times 8 times this h that we're trying to find. So literally the question is, what the h? The h we're going to figure out. So I can easily do this. 1/3 times 15 is 5. And then times 8 is 40. Come on now. 40. Do-overs. So 260 equals 40h. We divide both sides by 40. We're going to get 6.5. Look at those guys. Is our height. The height is 6.5 inches. Sweetness? Sweetness. All right, so turn the page. All right, pause the video, do guided practice 3 and 4, and then unpause. There we go, $, ampersand. All right, unpause the video. All right, so your answers should be, the volume of the pyramid for number 3 is 12 centimeters for the height. And the rectangular pyramid for number 4, the height is 11.6 meters. 11.6 meters. If you got that, then you can skip ahead to the point where it shows you the red place symbol. Otherwise, watch me do them. So a square pyramid has a volume of 400 cubic centimeters, number 3. Square pyramid, volume of 400, the length of the base is 10. Okay, I'm going to just start by writing my formula. V equals 1/3, capital B times lowercase h. They give us the volume, 400. You know what, let's switch colors. $400 equals 1/3 times the base. This time, let's figure out the base. The base is 10 10 by 10, which is 100. So it's 1/3 times 100 times our mystery variable h. So 100 divided by 3 would be, I mean, it's annoying. 33 1/3, obviously. So 33 1/3 times h, divided both sides by 33 1/3. I don't know. Let's see. Yeah. Divide both sides by 33 1/3. What I do is I hit reciprocate with my 33 1/3 and then multiply. Because multiplying is the same as dividing by a reciprocal. So you should get h equals 12, and it's centimeters. All right. Now, sorry, I had to get up real quick. Number 4. Number 4. A rectangular pyramid has a volume of 58. The sides of the base measure 3 by 5. What's the height of the pyramid? V equals 1/3 BH. If you rewrite this every time, guys, it'll start to get like second nature that you know what these formulas are. So I would just recommend doing it at the start of every one. So the volume is 58. One-third times the base is going to be, what did they give us? 3 by 5. So 3 by 5 is 15. So 15 times h. 1/3 of 15 is 5. So we have 5h equals 58. 58 divided by 5 gives us 11.6 meters high. That's how high our pyramid is. Should we draw it? That looks like a pretty good scale if you ask me. I think that looks pretty good. Oh, yes. Yes, it does. Okay. So if you left us, rejoin us. Here we are. So erasing my board. Great thing about this whiteboard, you never have to spray it with that chemical stuff. It always just works. They should make a more realistic whiteboard that leaves a bunch of little gunky residue all over the whiteboard. So to find the exact volume of a cone, we're going to use 3.14 to approximate pi. To find the approximate value of the cone, round your answer to the nearest tenth. So once again, the formula is still V equals 1/3 capital B lowercase h. But this time our B is going to get calculated differently, right? This is the trick right here. So we're going to see this in action here. So if they say, oh, they gave it to us in a picture. So the height is 7 and the radius is 3. They take 1/3 times, the base is going to be, in this one, pi r squared. Pi, the radius is 3. We're going to square that, so it's going to be pi times 9. And the height is 7. 7. And we're going to divide it into thirds. And that gives us 65.9 cubic centimeters, because We're in 3 dimensions now, guys. Everything's cubic. Look at what enthusiastic math student says. Sometimes it's convenient to just leave the answer in terms of pi. This gives you an exact answer. Exact answers are especially useful if you are combining results of 2 or more calculations that involve pi. We saw that a little bit in the last lesson because by leaving it in pi, you are able to get pi out of there, and then you get a perfectly round answer that doesn't have any decimals in it. So an example of that would be let's see, how do we do that? So the volume equals, backing up. So it would just be 9 times 7, which is 20, oh, 1/3. Yeah, 1/3 of 9 is 3. 3 times 7 is 21. So you could just say, hey guys, it's 21 pi is the volume of this cube. And then leave the pi there instead of multiplying it out. Not only is it more convenient for a lot of neatness and things like that, it's in one way less work. And I know some of you are really interested in doing less work. So pause the video and do guided practice number 5 and 6. All right, so you've unpaused the video. You've done guided practice 5 and 6. Good job. I know you did it correctly. Because now we're on page, ooh, I just murdered the whole thing. Page 145, guided practice 5 ampersand 6. Oh, fine, whatever. The answer to the volume of the party hat in cubic inches, if you give the exact answer, it's 168 pi. The approximate value is 527.5 cubic inches. That's number 5. Number 6 would be 94.5 pi cubic centimeters, or 296.7 cubic centimeters. Let's see it get did. So the party hat is in the shape of the cone. Find the exact volume of the party hat. 3.14 is approximate pi. Okay, so the height is 14 and the radius is 6. So V equals 1/3 of the B times the H. Remember, we're looking at our base is a circle. So it's going to be pi r squared. So that's going to be, I'll just rewrite the whole thing. V equals 1/3 times pi times r squared is 6. So r is 6, so r squared is 36. And then the height is 14. So 1/3 of, I'm just going to multiply these two pieces right away. 1/3 of 36 is 12. So we have the volume equals 12 times 14 times pi. And so 12 times 14 is 168. You can leave it 168 pi and be exactly right. Or you can be approximately right, which is good sometimes, and get 400, excuse me, what? Yeah, 527.5 is approximately equal to 527.5. See, I'm drawing my fives like some of you do, where you start with the hat and then work your way around. Makes it easier to connect on this whitey board thing. And we're dealing in inches cubed. Which, guys, that sounds huge. I'm not going to lie. That sounds really, really big. A 14-inch tall hat. Yeah, I don't know that I've ever seen one that big before. It's enormous. So to Josiah's point, yeah, it's completely unrealistic and weird. Okay. Now then, number 6. The diagram shows a cone-shaped container. See, if I'm going to deal with 14 inches tall of something, it better be a 14-inch tall, like, snow cone with a 9-inch cup. Oh my gosh, that's huge. Let me eat that snow cone. Or maybe it's a cone filled with gourmet popcorn from Candy Wrappers at 123rd Court. Shameless plug. I don't even really know those people very well. Anyway, the diagram shows a cone-shaped container. Find the exact volume of the container, blah, blah, blah. Okay, so once again, I'm going to start by drawing V equals 1/3 of the capital B times the H. That capital B, since we're dealing with a circle again, is going to be pi r squared. So let's plug that in. Let's use green. 1/3 times pi. The radius is 9. 9 times 9 is 81. I'm just going to go ahead and square that r. 81 times 14 again? Why did they give us the same height? I think I already mentioned that. So let's see, is any one of these easily divisible by 3? Yeah, I believe 1/3 of 81 is, oh, don't tell me, 27? Because 9 times 9 is 81, but 3 times 9 is 27, which is 1/3 of 81. That's how I did that. So we have 27 times 14 times the pi. That was the worst pi ever. It's like pecan pie. Ugh. I think I'm sour on pecan pie because there's like one of the first early times I had it, the pecans were kind of badly burnt. They left it in too long, or the crust was burnt. It was just left a bad taste in my mouth, quite literally. So, oh yeah, and a third. No, wait, I already did the third. Hang on. Why am I wrong? Why am I wrong? Oh, guys, I did it. Oh, I fell into the trap. The radius is not 9. Shoot. What's the radius, you guys? Oh, the radius is not 9. The diameter is 9. The radius is 4.5. Gross. 4.5. Which really going back to the party hat, who in the heck has a 1-foot diameter head? That is redonkulous. That's like a party hat that clowns drive cars out of at a circus. Anyway. So 4.5 squared, it's 20.25 decimals. Thirding that would be almost 7. 6.75 times 14 times pi. 94.5 pi. So here's the final verdict, the final answer. Zippity bippity. 94.5 pi centimeters cubic, which is approximately equal to 296.7. Ugh, guys, as your math teacher, I really hate falling into the traps that they set for you guys. Sometimes you fall into your own snare. I feel like there's a proverb about that. He who digs a hole falls into it, or something like that. I dug myself a hole. Oh, all right. So if you left us, please rejoin us. Because we are on Doink. Example 9er. Yes, this is a walkie-talkie. Oh, safety cone. Doot, 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 doot. It's a song before your time. If you know that song, oh my gosh, please comment me. We can dance if we want to. We can leave your friends behind. The safety cone has a height of 30 inches and a volume of 2009.6 cubic inches. What's the radius of the safety cone? Excluding the little basey thing. Just treating it like a cone. They just want a cone. All right. So let the radius be equal to r, be r inches, the volume. So we're going to say v equals 1/3 base times height. We're trying to find the radius. Let's expand this out. So the v equals 1/3 times pi times the radius squared. This is the thing we're trying to find. This is where it gets a little bit challenging now, guys. All right, show up. Wake up. This is gonna get real right now. It was real-ish before, but it's really real this time. This is our variable, is r squared. The tricky part, as you will see, is because it is squared, we cannot unsquare it until we're like absolutely ready, done, like at the end of the algebra. Otherwise, you're going to get really screwed up answers. Don't try to unsquare this, square root this until it's time. It's not ready yet. It's like kneading the dough when you shouldn't knead the dough. I don't know, I'm not a baker. I always knead the dough when I'm not supposed to, and it gets crappy because you didn't do it right. So let's do it. So it says to approximate pi with 3.14. I think it's good advice right here. So 1/3 times 3.14 times r squared. We have the h. What the h? The h is 30. Equals our v. Our v is 2000. We also have that too. 2009.6. Could they make this any more convoluted? Well, they are doing it for a reason, because it's all right. That way our answer will end up being a nice, beautiful round number. That's why. I know. Whose side are you on, Mr. Bourgeois? I'm on their side, not yours. So let's combine some terms, make this a little bit cleaner. Easy peasy math right here. 1/3. I can multiply 1/3 times 30 and just get a 10. So we're going to have 10 times 3.14 becomes 31.4. That's easy enough. Times r squared equals the 2009.6. So now we have 31. So 1/3 times 1/3 times 30 is 10. 10 times 3.14 is that. I can do that in my head. However, this I don't want to try to do in my head. Divide both sides by 31.4. Really, this is the order you have to do it in. I know that a lot of the problems, you can kind of do different things in different orders. You really can't do this in any different order and have it go well for you. You kind of have to do it this way. So 2009.6 on my calculamatron divided by 31.4 is 64. Aha! That's why they told you, hey guys, use 3.14 as an approximation for pi. Seriously do that, because otherwise, here, I'll reward you. Galaxy pen, because then it works out better that way for you. So just seriously do it. I said so. If you try to use pi, you're going to get some wonky decimals at the end of it. 64 equals r squared. Now we square root both of these. Here, let's square root with rainbow pen. The square root of 64 is 8. The square root of r squared is pretty much just r. The radius is 8 inches. Not 8 cubic inches, not 8 square inches, just 8 straight linear inches. Fun times, you guys. Turn the page. Yar, we be on page 146. This would be a good time to pause the video and go get a snack. I do not have that luxury. I don't have snacks. Just kidding. We're doing guided practice. 7 and 8. Hit it, you guys. Pause the video. Unpause the video because you finished 7 and 8. Your answers. I'm really not terribly concerned if you fill in all those little blanks. I know I've said it once and twice, and I'll say it again. Just get the final answer. Don't worry about what blanks are they're doing. They're trying to help you set up the problem correctly, which I appreciate. If you need help setting the problem up correctly, maybe that's helpful. If you still need help, then I guess it's not so helpful. But the radius of the cone is about 7 centimeters. 7 is 7. And the answer to 8, the radius of the cone is 5 inches. 5 inches. If you would like to see it demonstrated, it's coming right about now. A cone has a height of 57 centimeters and a volume of 2,923.34 centimeters. Good grief. Do I have to write that all? I guess I do. It's just hard on this screen. Use 3.14 as an approximation for pi. What's the radius of the cone? Volume equals 1/3 capital B lowercase h. I can drink water while I write, and I don't have to talk while I do that. Good grief. What is it? A cone, which means the base is a circle. So 1/3, here's the base formula, pi times r squared, and the height is 57. Boom. Okay. Now then, yoink. 57 does divide evenly by 3. I feel like I should know that. It's not going to be 20, it's going to be 19. Because 60 would be 20, which means 57 would be 19, right? Let me check on my calculator. 19, ha ha, I was right. So we have 1/3 plus times 57 equals, ouch, my skin's getting dry. 19 times pi times r squared, but our pi is going to be 3.14. So 19 times 3.14, 59.66. So what did I just do? Times r squared equals our 2,923.34. We're going to divide both sides by 59.66. Oh, it divides evenly. Surprise, surprise. Divides into 40, becomes 49. So, whoop. So 49 equals r squared. We're going to square root both sides. Square root, square root. Oh, hang on. Done inking? That's so weird. Done inking. Weird. All right. I have to do this, you guys. Otherwise, I die. 7 equals r. So 7 centimeters is the radius. Skadoosh. Skadoosh. All right, that was numero 7. Now, numero 8. I'm starting to get stuffed up again. 8. A cone has a height of 7.2 and a volume of 188.4 cubic inches. What is the radius of the cone? Same situation. 1/3 times the b times the h. We're dealing with the cone, so this is going to be the pi r squared. So volume is 188.4. I feel like I've seen that number somewhere. It must be somehow divisible by something that I've done before in one of the math problems I've ever done in my entire life. Just feels like I've done this one before. So the height is 7.2. We don't know the base, but we know that there's a pi in it, and there's an r squared in it, and the height is 7.2. Yes, I feel like the 72 and the 1,884 is something that I've done before with like finance math, sometime. Righty-ho, moving on. So 1/3 of 7.2. I know that divides evenly. I'm going to use my calculator though. 2.4. I should have been able to figure that out in my head, but my brains are starting to melt away. Times 3.14 R2. 7.536. We're going to divide both sides by that. Let's not forget our little r squared and our equal sign. Divide both sides by 7.536. I'm just going to hit the reciprocate button on my calculator. So the reciprocal of 7.536 times 188.4 equals 25. Excuse me. Sorry for that. 25 equals the square of r. We square root both of those. We get 5 inches is our radius. Galaxy pen. Look at the stars. Sorry. ADHD attack. Okay. Moving forward. Guys, example 10. Suzanne is serving yogurt in a cone-shaped parfait glass. The cone-shaped part of each glass has a height of 9 centimeters and a diameter of 7. A diameter of 7. How many cubic centimeters of yogurt can Suzanne Can Suzanne serve as she fills 3 parfait glasses? Write your answer to the nearest tenth. This is tricky because she said she's filling up 3 glasses. And she gave us the diameter. Suzanne, okay. I'm going to immediately write the radius before I forget. 3.5 centimeters. Okay. So that's what they do first. They show the radius is 3.5 centimeters. They calculate out the volume, and they multiply that by 3. So they find the volume of 1, they multiply it by 3. They give you 346.2 cubic centimeters if she fills in those things. So it's the same thing we've been doing. Do it for number 9. I'm sorry, I forgot to do this. That's the wrong color. Rejoin us. We're doing guided practice number 9. Pause the video. Okay, unpause the video. Guided practice number 9. Let's do it. Jean wants to sell lemonade in cone-shaped paper cups. Bad idea, Jean. Get the regular cups. Each cup has a diameter of 4 centimeters and a height of 8 centimeters diameter. She wants to make enough lemonade for 50 cups. How much lemonade does Jean need to make? Let's hit it. So the radius is 2 because that's half of the diameter. Okay, so the volume equals 1/3 B and H. So that's going to equal 1/3 times pi times r squared which would be 2 squared, which would be 4. And the h is 8. Sweet. So 4 times 8 is 32. Divide that by 3, you get 10 and 2/3. Ugh. So 32 divided by 3 is 10 and 2/3. Pi is the volume of 1. They're giving it to you in cubic centimeters. Just so you know, I think that that's a ridiculous amount. All right, so we multiply that by 50. Hang on a sec. Hang on just a second. 32 divided by 3, 10 and 2/3 times 3.14. You get 33.49 times 50 cups equals 1,674.7 centimeters cubed, which is also milliliters. That's the fun thing about metric, is centimeters cubed coincidentally equals milliliters. I am nearly 100% positive. A milliliter is the amount of liquid that fills up 1 cubic centimeter of space. I'm like 95% sure of that fact. We might have to talk to Mrs. Leitner about it later, but I'm pretty sure that's true. So that's the volume of 1. We multiply that by 50 with our Galaxy pen. We will get, no, Galaxy pen, come back to me. Milliliters. Superfluous. All right, surface area of a cone, you guys. Surface area of a cone. We're moving on. Replay the video. If you left us, if you were fast forwarding, stop it, stop, and play at normal speed. All right, what is going on? My computer's acting funny. That would suck if I lost this whole video that I'm recording so far. Woo! Surface area of a cone. So the length from O to A on a right, if they show the, like if it was a piece of paper unfolded, unfurled, the length of the from O to A on a right circular cone is called the slant height of that cone. The slant height is the height of slantiness. And it says a right circular cone is a cone that has its vertex directly above the center of its base. That means it's symmetrical, right? Wrong. Means it's symmetrical. It's a straight up and down cone, not like what I just drew. But if you drew it out and were really good at drawing on a weird tablet thing like this, the vertex would be directly above the slanty thing. But the surface area formula only works, see the blue box, math note? The surface area formula only applies to a right circular cone. So the slant height is the distance between the vertex and a point on the circumference of the base. When you cut the cone along OA and flatten it, you will get a portion of a circle with the center O and a radius of whatever that swirly Greek letter is, L units. Reminder, slant height is different. So turn the page. We were on page 170, 147. I've been bad about updating my page numbers. We are on page now 148. Page 148. There's a hands-on activity. It's kind of cool. They show how you can kind of find out the surface area of a pyramid, of a cone, by kind of evolving and adding more sides to the base of the cone. And you see that it begins to take shape. For the curved surface, you need the slant height. I wish I knew the names of some of these swirly little letters that they do. But we're going to skip ahead to page 149. Okay. To find the surface area, you find the sum of the area of its base and the area of its curved surface. The curved surface is called the lateral surface. Lateral means side, enthusiastic math student from Hawaii 5.0, Kid Edition. So Hawaii 5.0 says lateral means side. Prisms, pyramids, cylinders, and cones all have lateral surfaces. The lateral surface area of a solid does not include the area of the base. It's just this curvy derby right here. We'll use rainbow pen. Just this curvy derby part right here that goes up. It's the cone part of the cone, not the circle part of the cone. So the area is this thing, pi times the radius of the widest part times the woohoo slant height. That's the area of the curvy thing. The area of the circle at the bottom is added to it. We already should know the area of a circle is pi r squared. So these two pieces form, there's that, and then there's that. They form the total surface area of everything. Does that make sense? Remember, back on page 147, I'm doing it in rainbow pen so that you see that they're the same thing. Page 147, they show you the area is a part of a circle. It's like a partial circle. Like you take a circle and you cut a little piece out of it. The little piece depends on what the slant height is, this weird swirly L thing. That slant height tells us, it would be like kind of like a radius, but it's not. The slant height tells us how much of a circle chunk we've cut out to make the cone part. Rainbow pen's kind of hurting my eyes. I hope it's not hurting your eyes too. So we're taking some time to digest that just a little bit. We're going to turn the page. We're on page 150. I know it's been going a little bit long, you guys, but usually Wednesday is my longer class. So yeah. Example 11, we're going to find the area of the curved surface of the cone. So we're going to find, remember there's, just like with the cylinder, how there's a curvy surface and then the circles at the bottom and the top, we're just going to find the curvy surface, the slanty part. Let me finish erasifying this. We'll erase the whole thing. If you needed it, hit rewind and look at it again. Meditate deeply on those truths. So, what is the exact area of the curved surface of the cone that's given in that picture on example 11? Come on. So the example 11, it's a 15 is the slant height. They give it to us. Rainbow pen. So we're trying to find the slant height right here or we're not trying to find the slant height, they give us the slant height. It's 15. It's 15. They also give us the radius is 5. So we're going to find the surface area, which would be like how big your piece of paper needs to make a cone that's open at the bottom. So no paper at the bottom, no paper on the base. So they say, what is the exact area? When they say exact area, it means don't approximate. So you have to leave your answer in pi. So we have the formula for the curved surface is pi times the radius times the slant height. Let's plug these numbers in. Pi is still pi. The radius is 5. The slant height is 15. So the exact surface area of this thing is 5 times 15, which is 75 times pi. Now they say, hey, what's the total surface area of the cone? So B, what is the total surface area of the cone? So it's going to include this. It's going to include this part, the curved surface, but we're going to add to it the area of this circle at the bottom. So the circle at the bottom is pi r squared, pi times 5 squared, which would be 5 pi times 25. So the total area is 75 times pi, plus 25 times pi. I also want to show you something. This is important, and the book tells me that I should show it to you. We can factor out the pi like this. This whole thing, oops, I hate when that happens. This whole thing is equal to pi times the quantity of 75 plus 25. See how I did that? Because pi is multiplied by this term and by this term, I can factor it out. If you guys remember how to factor, and I get pi times 75 plus 25, which is the same as 100 pi. So for those of you who are like, why do we ever need a factor? Because 100 pi is so much easier and simpler of an answer than this 75 pi plus 25 pi. If I have 75 of a pi, or it's not a variable, it's a number, but if I have 75 pi and I have 25 pi, my total is 100 pi. See how that works? Very cool. Okay, guys, many of you are tired. Many of you are stressed. That's good. You're in a good place right now. Go ahead and do guided practice number 10. Solve it. All right. Good job, guys. Thanks for letting me erase this whiteboard. So it says a solid cone, number 10. The answer should be 98 pi. That's your answer. If you got that, you may skip. I will try to wake you up when it's time to not skip anymore. A solid cone has a radius of 7 and a slant height of 14 inches. What is the exact area of the cone's curved surface? Oh, 10 goes on to the other part. Okay, so B, the total surface area is 147 pi, also known as approximately 462. We'll do 11 too. All right, so pause the video, do a 10 and 11. I didn't even notice that it kept going. Okay, now unpause the video, now that you've done 11 also. Yep. Fun times, you guys. Okay, so 98 pi is what we're after, because I already gave you the right answer. So we're just going to plug it in. So what is the thing? The area of the slanty thing equals pi times r times that weird slant height. We get it right here. So pi, the radius is 7, the slant height is 14. 7 times 14 is 98, so the exact area of the swirly whirly part is 98 pi. Part B, it says use 22/7 as an approximation for pi. You got it. So it says, what is the total surface area? Well, we already have this part. We already have the slanted part. We need to add to it the base, which is the circular bottom of that cone. So our r is still 7. So it's going to be, we'll use this one, pi r squared, which is the same as, 7 times 7 is 49. Let me rewrite that. 49 pi. So the exact answer, 49 pi plus 98 pi, is 147 pi, because we add these two pieces. We have the circle on the bottom, we've got the cone on the top. The slanty part here is 98. The circular bottom is 49 pi. So the total is 147 pi. And they said to use 22/7 to approximate pi to get an approximate answer. So we're going to say it approximately equals, we're going to use our calculator, 22 divided by 7 equals that number that looks really close to pi, times 147 equals 462. 22/7 is a really wonderful approximation for pi because it terminates. False, it repeats. Excuse me, it doesn't terminate, it repeats. And because it repeats, your calculator can reconvert things back into whole numbers as you do calculations. All right, let's do number 11. 11 should be, number A is 36 pi inches squared, and number B is 45 pi inches squared, or approximately 141.3 inches squared. Let's do it together. Radius is 3, the slant height is 12. Okay, so number A. So, pi times r times swirly, slant height is 3 times 12 times pi, so the answer is 36 pi. 36 pi rainbow pen. Inches squared. Square inches because surface area is in 2 dimensions. I know it's a 3-dimensional figure, but when you flatten it all out, it ends up being two-dimensional piece of paper. So the total surface area, we just take this and we add the area of the circle, which is pi r squared. The r is 3, so pi times 9. So the total would be 45. So this plus this, excuse me, would be 45 pi inches squared. And they say, what did they say? Use 22/7 as an approximation for pi. No, it says, this one says use 3.14. Okay, we're going to change it now for some reason. So 3.14 times 45 is 141.3. It's about equal to 141.3. There we go. All right, if you skipped it out, rejoin us. We're looking at example 12 on page 151. Dupe. Okay, so find the slant height of a cone given its radius and the area of its curved surface. We're just working backwards again like we always do. This is the last thing we're going to do, sort of. No, not quite. All right. So they say they give us the area they're going to ask us to find the slant height. That's right, start by formula writing. So the area equals pi times r times slant height. Specifically the rainbow pen area. I know rainbow pen used to mean something in the last chapter. It means this now. It means the slant height area, slanty part area. So it says if the area is 159 and the radius is 4 times pi times slant height, then use 3.14 as an approximation. What's the slant height? Question mark. Let's divide both sides by 4 pi. 159 divided by 4 divided by pi. (159) divided by 3.14 equals that. Divide that by 4. You get 12.7-ish. Is about equal to the slant height. All right, turn the page. Pause the video, do guided practice. Number 12. All right, good job doing guided practice number 12. Unpause the video. A conical straw hat with a diameter of 16 inches. That's gigantic. And a lateral surface area of 251.2 square inches. Find the approximate slant height. We're doing the same thing we just did last time. The answer should be about 10 inches. Here's how we do it, so you can pause and rejoin us later. About 10 inches. Ah, the phone's ringing. Okay. So that's really annoying and distracting. Okay. So once again, area equals pi r slant height. The area is given as 251.2 equals pi times r times slant height. The r is given as, I'm just going to go ahead and pen it in. The diameter is 16. The radius is half of that. Maybe that tripped you up. So let's see. So they say to use 3.14 as an approximation. So we can 3.14 times 8 is 25. 25.12, 0.12 I should say. Oh, look at that. We can divide both sides by 25.12. We're going to get 10 is the slant height. Cool, you guys. I'm going to just go ahead and skip example 13. I don't know. We can do it. Real world problems. It says a cone-shaped roof has a radius of 14 feet, and a slant height of 17 feet. The roof is completely covered with glass. Glass costs $40 per square foot. What's the cost of covering the roof with glass? So they find the surface area of the curved surface, pi r times slant height. They multiply that by $40 per square foot, and they get very nearly $30,000. You see that? Try guided practice number 13. Cool. So filter paper. So Jessica makes a cone-shaped paper filter to line a cone-shaped funnel. The funnel has a radius of 5 inches and a slant height of 10 inches. Suppose Jessica wants to make cone-shaped filters for 25 such funnels. How many square inches of filter paper will she need? So we're trying to find the slant height. We're not going to cover the opening of the funnel. We're just going to line the outside rim up the funnel. And so we just need enough square inches of filter paper to make 25 funnels. So they give us all the pieces we need. This time we're just calculating the area. Area equals, oh my gosh, really? Come on, finger, don't fail me now. Area equals pi times radius times slant height. They give all those pieces to us. We're just going to plug them in. Pi, the radius is 5. The slant height is 10. So 50 pi. They say to use 3.14 for pi. 50 times 3.14 would be give us the surface area needed for 1. 157. Sevens need mustaches. Multiply that by 50, or not by 50, by 25 funnels. $3,925. That's all she wrote, you guys. It's over. You did it. Good job. Now you are equipped to do the homework and get a snack. I know, I'm sorry this one went long. Hopefully you guys didn't have to sit and watch me do every single guided practice problem, but were able to skip some of those parts. Anyway, Godspeed, good luck. Love you.